Okay, let's very quickly review what we did in the last video. So we had a curve, let's say call it the curve f of x equals x squared. So there's the curve f of x equals x squared. Here's the f of x axis, and here's the x axis. And we wanted to find the slope of the curve. So what we did, we picked a point on the curve. We wanted to find the slope of the curve right here. So what we did, we picked a second point on the curve and we drew a line between those 2 points, and we found the slope of this line, which we said approximated the curve. So let's say this is the point 1, and then the corresponding y value would be 1. 1 squared is also 1. And if this is the x point, let's say 4, then the corresponding y value, so 4 squared is 16. So the corresponding, just draw a dash line across, so that'd be 16 because 4 squared is 16. So now to find this, remember we want to find the slope here. So we've drawn this line, we've picked another point on the curve, and we're going to find the slope of that line, which is an approximation to the slope of the curve. So the slope of the curve, or of that line really, it's going to be 16 minus 1, the change in the y values, 16 minus 1 divided by the change in the x values, so divided by 3 minus 1. 16 minus 1 is 15, divided by 3 minus 1 is 2. So we guess the slope of that line will be 15 divided by 2, or 7.5. Okay, so that was what we did in the last video. So we're going to do something very similar in this video, but instead of filling in numbers here, we're going to call this value x, because x can represent any number. So, okay, at the moment I have this point as being, this x value as being 1, but say I wanted to find, say if that was 2, and then that would be 4. Say if I wanted to find the slope when x is 2, I would have to do the whole process again. Or if this was 3, I'd have to do the whole process again. So rather than call it 1, 2, 3, or 4, or whatever, I'm going to call it x. And we're going to find, what we're going to do is we're going to come up with a formula. We're going to come up with a way to find the slope at any value of x. So you'll see when I do this over here. Okay, so let's go again. So we've got the curve f of x is equal to x squared, which is this curve here. I'm going to call this point x. And what I'm going to do is I'm going to go a short distance across. So I'm going to come across here. And I'm going to say the distance I move across is h. So this would be the point x plus h. Like in the previous video, or the previous page, I said this point was 3, say, and then I went a short distance across, and the short distance I went across was 1. So when I went across 1, this point will be 4, or this x value will be 4. So if this is x, I go short across a distance h, this x value is going to be x plus h. So what's this point, and what would this point be? Those 2 points. Well, the curve is f of x is equal to x squared. So when x is x, this is going to be x squared. And when the x value is x plus h, which it is there, the corresponding y value would be x plus h squared. So x plus h squared. And now we're going to find the slope in exactly the same way. So the slope of that curve, or of the line between those 2 points, so this line here, is going to be the change in the y value. So it's going to be x plus h squared minus x squared divided by x plus h minus x, x plus h minus x. So it's just the change in the y values, this minus this, divided by this minus this, which is exactly what we've been doing before. Now x plus h squared, let's do it over here. X plus h. So x plus h squared is x plus h times x plus h. So it's x by x, which is x squared, plus x by h, which is xh, plus h by x, which is hx, and xh and hx are the same thing, and plus h by h, which is h squared. So I'm left with x squared plus twice xh plus h squared. So that's that part there. So the slope is equal to x squared plus twice xh plus h squared minus x squared, all divided by x plus h minus x is h. Now if you look at the top, we can simplify it, because x squared minus x squared will give us 0. So we're left with 2xh plus h squared, all divided by h. We can divide h in. H into 2x, h goes 2x times, and h into h squared goes h times. So we're left with the slope is equal to 2x plus h. So if you remember in I think it was the first or second video that we did, we found the slope of the curve in this way, but we found that we got a better approximation for the curve if these points, if this x value and this x value were closer together. So what we're going to do now is one of the most important things in maths, one of the most important things that was ever discovered in maths. We're going to shrink this distance h, because if we shrink this distance h, then this point won't be up here, it'll move closer and closer to the other point. And the closer it is to the other point, the more the line that you draw between the 2 points will approximate the curve, the better the slope we'll get right here. So we're going to say the slope is actually equal to the limit as h approaches 0, so we're using limits here, so as h approaches 0 of 2x plus h. Whoops, 2x, I'm going to write that out again. So it's the limit as h approaches 0 of 2 times x plus h. And if I work out that limit, I get 2x, because as h approaches 0, I just get 2x. So what does that tell me? Well, that tells me that the slope is equal to twice x. So that means that if I want to find the slope at any point on the curve, all I have to do is look at the corresponding x value. If I want to find the slope of the curve x squared, all I have to do is look at the corresponding x value, and that'll give me the slope. So for instance, let's draw the curve out again here. So there's the curve y is equal to x squared. Let's mark in a few points now. So say there's 1, 2, 3. So when it's the curve f of x is equal to x squared, so when x is equal to 1, the f of x value will be 1, because 1 squared is 1. When x equals 2, so at this point, f of x will be 4. 2 squared is 4. When x equals 3, here, f of x will be 3 squared, which is 9. So I have all my points on the graph. So now let's say I want to find the slope right here. Well, I've come up with a formula for the slope down here. It said the slope is equal to twice the x value. So if I want to find the slope right here, all I need to know is what is the corresponding x value. And the corresponding x value for this point is 2. So the slope right here is twice 2, which is 4. So the slope right there is 4. Say if I wanted to find the slope right here, slope at this point, all I need to do is find the corresponding x value. And the corresponding x value for that point is 3. So the slope right there is twice 3, which is 6. And that makes sense, because the further up the curve that I go, the steeper we can see that the curve gets steeper. And that's what this is showing us. When the x value is 2, the slope is 4. When the x value is 3, the slope is 6. What about when the x value is, let's say, 0, right there? You can see that it doesn't seem to have any slope at all. Let's see if that's the case. So when the x value is 0, the slope will be twice 0, which is 0, which makes perfect sense. When the x value is 1, so right here at this point, I want to know what the slope of this curve is. So that's when the x value is 1. So the slope right there would be twice 1, which is 2. So this method of finding the slope, it's called differentiating from first principles. So you're going to see that phrase a lot, differentiating from first principles. Differentiating means finding the slope. And by doing it this way, it's called the method of first principles. Okay, I'm going to do this again, but I'm going to give you a formula that's going to help you to do it a little bit quicker, so you won't have to draw a graph or anything like that. So I'll come back to that page in a minute. So the formula looks like this. It says the slope is equal to the limit, which we worked out at the end there, if you remember, as h approaches 0 of f of x plus h minus f of x all divided by h. So that's a formula that you can use. Whoops, you couldn't see it there. So it's the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So if you remember, okay, we had the curve f of x is equal to x squared. So we wanted to find the slope of that. And when we did it this way, we found the slope of it was twice x. So we're going to do using this formula this time. So here's the f of x part. F of x is equal to x squared. So in the formula, when I've got f of x, I write x squared. F of x plus h just means anywhere there's an x, I'm going to write x plus h. So f of x plus h would be x plus h all to be squared, which is, when I multiply that out, it's x squared plus 2xh plus h squared. It's x plus h by x plus h. So now let's fill into this formula. So I get the slope of f of x is equal to x squared is the limit as h approaches 0 of f of x plus h, which is this, of x squared plus 2xh plus h squared minus f of x, so minus x squared, all divided by h. And if you look at this now, and if you go back to, let me see where I have it. Go back to the second line. Okay, this is what we did previously. And if you look at the second line there, I'm just going to fold the page over so you can compare the two. It's exactly the same. The only difference is I didn't have the limit written. I didn't have the limit as h approaches 0 written. But I've got x squared plus 2xh plus h squared, x squared plus 2xh plus h squared minus x squared, all divided by h. So both methods, this method, where I just did this minus this over this minus this, is exactly the same as this method here. But this method is a little bit quicker because I don't need to draw a graph or anything like that. So to finish this off, x squared minus x squared gives us 0. Divide h in here, so h into 2xh. Well, let's not skip a line, okay, let's write it out again. H approaches 0. We've got 2xh plus h squared, all divided by h. Now let's divide h in, so I get the limit as h approaches 0 of 2xh divided by h will give me 2x. H into h squared goes h times. And now let's work out the limit as h approaches 0. So as h approaches 0, this limit turns out to be twice x. Well, it's twice x plus 0, which is just twice x. So this here is the slope of the curve f of x equals x squared for every value of x. So it allows us to find the slope for any value of x. And that's exactly what we got over here, 2x. So again, let's just have a quick look. We can use that to find the slope. So here's the curve, f of x equals x squared. So we go 1, 2, 3, 4. This will be the y point 1, 4, 3, that'll be 9. And then we got 16. So say I want to find the slope when x is equal to 4. Well, when x is equal to 4, that's the point up here. I want to know what the slope is there. You can see it's quite steep. So when x is equal to 4, I want to know what the slope of the curve is. Well, the slope of the curve, so when x equals 4, then the slope is equal to twice 4. So twice 4, which is 8. And I said at the start that it's going to be quite steep, which it is. So now we have a way, here it is here, to find the slope of any curve. And in the next video, I'm going to show you how to do that. I'm going to show you how to find the slope of any curve. I'm going to show you how to use this to find the slope of any curve. And the method is exactly the same as we did here.